On the afternoon of 2 June 2026, a U.S. aircraft operating under Central Command executed a precision Hellfire missile strike against the Botswana-flagged MT Helexi, an unladen oil tanker transiting the Arabian Gulf toward Iran's Karg Island. The vessel had ignored repeated maritime warnings over a 24-hour period while violating the U.S.-enforced naval blockade initiated on 13 April. Thermal imaging footage captured the AGM-114 Hellfire impacting the engine room, producing a high-energy detonation that disabled propulsion machinery and rendered the ship immobile without compromising hull watertight integrity. This analysis details the core scientific principles: semi-active laser homing, shape-charge warhead physics, forward-looking infrared sensor resolution, and terminal guidance kinematics that delivered surgical disablement at extended maritime range. The aircraft's multispectral targeting pod locked onto the tanker using a cooled indium antimide focal plane array detector operating in the mid-wave infrared band between 3 and 5 micrometers. This wavelength penetrates atmospheric haze and marine aerosols while delivering thermal contrast that resolves engine room exhaust stacks, deck machinery, and hull plating against the cooler sea surface. The pod's laser designator emitted a coded 1.06 micrometer neodymium-doped yttrium aluminum garnet beam modulated at 20 pulses per second, painting a precise spot on the target's engine room superstructure. The Hellfire's seeker head, equipped with a quad-cell silicon photodiode array, detected the reflected laser energy and generated proportional navigation commands that steered the missile along a collision course trajectory. Hellfire employs semi-active laser homing with proportional navigation guidance law, continuously computing line-of-sight rate and applying lateral acceleration commands through 4 folding control fins. Missile velocity exceeds Mach 1.3 at burnout, yielding a 9-kilometer effective range when launched from medium altitude. Inertial measurement unit data fused with seeker line-of-sight measurements corrects for target motion and platform velocity vectors, achieving circular error probable under 1 meter in the terminal phase. For this engagement, the aircraft maintained stable designation geometry, while the missile executed a shallow dive angle optimized for engine room penetration. The 9-kilogram high-explosive anti-tank warhead utilizes a copper-lined shaped charge configured for behind-armor effect. Upon impact, the detonator triggers the Composition B explosive train, collapsing the liner into a hypervelocity metal jet traveling at 8 kilometers per second. Hydrodynamic penetration follows the Bernoulli equation, where jet pressure exceeds material yield strength by orders of magnitude, punching through 300 millimeters of rolled homogeneous armor equivalent or multiple layers of ship steel plating. The jet injects residual explosive energy and spall fragments into the engine room compartment, fracturing fuel lines, fracturing crankshaft bearings, and igniting lubricating oil reservoirs without generating sufficient overpressure to breach the outer hull. Thermal footage shows the millisecond-scale flash of warhead detonation, followed by a sustained white-hot plume rising from the impact site as secondary fires consume hydraulic fluid and residual fuel. The missile's tandem warhead configuration, if employed, first defeats any lightweight deck shielding before the main charge releases its jet, ensuring deep internal disruption of the main propulsion plant. Post-impact kinematics confirm the tanker lost way within minutes, drifting under prevailing currents while remaining afloat. The aircraft platform, likely an MQ-9 Reaper or AH-64E Apache, integrated the missile with Link 16 data link and secure waveform communications that transmitted real-time seeker video and telemetry back to the ground control station. Onboard processors performed closed-loop target tracking at 30 frames per second, fusing infrared pixel data with laser spot location to reject decoys or sea clutter. This strike represents the 6th vessel disabled under the blockade through identical Hellfire employment. Each engagement leverages the missile's 40-kilogram launch mass and compact 1.6-meter length to deliver effects from beyond visual range while minimizing collateral risk to crew or surrounding shipping lanes. Engineers refined seeker algorithms and warhead liner geometries using computational fluid dynamics models of jet formation and material interaction, ensuring consistent engine room neutralization across varying tanker hull configurations. The MT Helexi sustained catastrophic damage to its diesel propulsion plant and auxiliary systems, while the surrounding hull plating exhibited only localized deformation. Battle damage assessment from archived thermal segments confirmed zero residual propulsion capability and confirmed the vessel's inability to reach Iranian waters. The technical integration of laser designation physics, shape charge hydrodynamics, and high-resolution infrared imaging continues to provide U.S. forces with standoff precision that converts maritime blockade enforcement into measurable kinetic effects.